Hey, what's up guys? Welcome back to another Houdini tutorial where today we're going to be making this little bucket here. This is going to be a really, well, hopefully fairly simple procedural modeling tutorial. We're just going to focus on the model today. We're not going to worry about UVs or textures or rendering this thing at all. We're just going to do this, and then in a follow-up I will happily go over more of those other subjects. But let's dive inside. We're going to be going through how to make this completely procedural. You can see each piece colored differently here, so let's go ahead and get right to it. Okay, so I'm in a blank Houdini scene here, and I'm going to drop down a geometry node, and I'm going to name this bucket, and we'll dive inside. So I'm going to start by putting down a box, and I want to basically use this to make up my planks here. So I'm just going to sort of eyeball some numbers in here, see what I can come up with. Something maybe a tad shorter. Okay, that's fine. What we're going to do with this is we're basically going to go ahead and place it so the corner of this is on world 0, and there's a very specific reason why we're going to do that. So I'm going to right click on each of these, and I'm going to go, in fact I don't need to do that, do I? I can right click on this, and I can paste relative reference and get all 3 of these in our center group here, and for each one I'm just going to come in and divide it by 2 in the expression here, like so. And there you go. Our plank, no matter how much we size it now or reshape it, is always going to be spaced on that world 0 point. And that is exactly what I want. So I'm now going to put down a copy and transform node. I'll plug that in here. And I want to basically move copies of this along by however wide this plank is here. So let's go ahead and do that. How wide is this thing? This is just 1 grid unit wide, so that's cool. I can copy this parameter, and I'm going to paste relative reference into the translate x, like so. And if we turn the display flag on, okay, cool. We've now got our a duplicate of our plank moved over a bit, and I can move this slider up like so, and get as many of these as we want. So I want, say, 20 divisions or 20 planks. We've got 20 planks. Cool, that all makes sense. Let's put down a poly bevel, there it is, and I just want to bevel these a little bit, because at the moment if I just turn this into smooth wire shaded, you can't really tell that there's any difference between these, so I want to add a little bit of that. I'm going to set this to go for 0.1. Let's just go to flat shaded for now. That's definitely a bit too much. We're going to go 0.03. Yeah, looks alright. Might want to go a bit more aggressive, 0.4, something like that. Now you see this is actually generating a triangle up on every corner. The way to remove this is to set the divisions higher than 1, or to an even number. And you can see that's now created some quads up on each of these corners, just so we keep our mesh quadrangulated where possible. So that's all good. So now we've got this, and this is cool. This will operate procedurally. We can scale back and scale up the number of planks we have, but we want to get this into a bucket shape. So I'm going to put down a bend sop, and I'll plug this into our first input. Now with the bend sop, what I want to do is I basically want to set a capture region that's as long as this set of planks is. If I turn on our control handles here, so currently you can see it's bending in the wrong axis. If I bend this, it's going to do something hella weird. Let's not have that. I want to capture it along x. So that's the first thing I'm going to do. The origin is fine because we've already set our box to be at world 0, the first point on our box to world 0. So let's change our capture direction to 1 in the x and 0 in y and z. And then I want to change the length. Now at the moment the length is just 1 grid unit, and that's not really going to work for us. We obviously got something that's much longer, but we can work out exactly what this is. So we know what the size in x is, and this could change, by the way. If I scale this up, the copy is picking up that value and moving each box over. So what do I want to do here? Well, I want to say the length of our bend capture should be the size of 1 plank. So where are you? Capture length, paste relative reference. So we want to do that multiplied by the number of times we copied it. So let's go ahead and implement that. Take our expression, multiplied by, and that. And now you can see our capture length is set to the length of all of our planks, and I can go ahead and bend this like so. And you can see this works procedurally. If I come in here and change the size of our plank, the bend still captures the full range, and likewise if I change the number of planks we've got here, it still captures the full range. That's never going to change, so that's great. Let's set our size back to 1 and our number of copies back to 20 just for now, like so. Set that back to 0. So the other thing you'll notice obviously is this bend is happening in the wrong axis. We don't want it to bend along this direction. So we just need to change our up vector control. So our up vector is basically at the moment saying, hey, I'm bending in the y-axis, and we don't want it to do that. We want it to bend in z. We want it to bend round along here. So I'm going to set this to the z-axis, and I'm going to set this to 360 degrees. So we want it to bend all the way around, and voila, we've now got all of our planks in this cylindrical formation. And I can again change the number of copies. It's always going to keep up. I can change the size of the box, nice and easy. So this is a really nice little procedural system here, but let's go in and make it a little bit better. What I'm going to do is I'm going to place down a transform, and what I want to do is I want this to sit on world 0 now. So I'm going to shift it over. Well, I want it to stay on the ground, but I'm going to shift the whole thing over to be at world 0. So how are we going to do that? Well, I'm going to start by I need to figure out what direction first. So okay, we need to move it in Z. We need to move it over by, what's that? Maybe 3, -3. View top viewport. Okay, it's not quite it. Is it 3, 2? The point is we're never going to get this exactly right. We could, you know, try and fiddle with it all day. It's just going to be a pain. We could do this move centroid to origin thing. See how close we were. We can click this button, and this is really cool. If I just show you that in the perspective viewport again, this move centroid to origin thing will basically snap something, the centroid of whatever's plugged into it to world 0. This doesn't happen dynamically though, so if we were to come in here and change this, you can see this hasn't updated. I can click this button again, but we want to do it dynamically. So since we've got such a simple thing, we can do that. So how are we going to do it? Well, I'm going to use a B-box expression. I'm going to come in here. I know I want to move it on Z, so I'm going to say, hey, give me the bounding box of whatever's coming out of bend 1, like so. And you can see when I start typing this expression, it's going to give me all the things that I need. So this needs to be a B box, and then I've got a string value in here, which is our surface node, and then the float here, which is the type of operation. So you can see actually this dx min, dy min, z min, max, size, and all of this stuff. We can get this, and you can actually, if I just click off for a second, it's going to be shouting at me. If I look at the information here, you can see what my min, max, and size are right here, which is really, really helpful, and what the centroid is. The centroid is a different expression, but in this case we can input that y min or z size or whatever we want, and I'm going to do that. I'm going to plug in, or I'm going to type rather, our z size in here, and see what that gives us. Okay, so this has moved it over by the whole length of this thing. If I reference on our bend, it's taken the size of this whole thing and it's moved it over. And I don't want it to do that. Two things I don't want it to do is one, move it over by the whole size, and also I don't want it to move over in this direction. So we need to do a couple of things. The first thing I'm going to do is I'm actually going to divide this by 2, just by popping that divide by 2 in. I'm going to put it in the wrong place. I need to put it outside the bracket, which means I need another bracket around there. And you can see now it's only moved it over by half the size of our bucket, or our cylinder of planks. So okay, that's kind of cool. I just need it to do it in the other direction. So let's put multiplied by -1 in here. And there we go. It's now snapped it over to our world 0, which is exactly what we wanted. And we know this is world 0 because we set this box originally to be aligned to world 0. So that's fairly successful. What else do we want to do with this? Well, to taper it. I want to do something kind of nice to sort of make it less of a straight profile here. You can see in my original bucket it was a bit more like this. So let's do that. The bend function actually has quite a the bend sub, sorry, has quite a lot of functionality. If I come in here, I can set up pretty much the same stuff that we had before. I can turn off the bend. We don't want to use that this time. I'm going to set the capture length to well, that can stay at 1 for now. Let's set the capture direction. How do we want to do this? We want to capture it in Y, so that's all good. But I also want to set the length to be the height. So I'm going to come in here, right click, copy parameter on our Y parameter here, and paste that into the length. And boom. Now this is captured all the way up. But rather than turning on bend, I want to turn on taper. And I'm going to come in here, and I'm just going to offset this out a tiny bit. Maybe not that much, that's a bit too much. Maybe do I want to go E15? Something like that. This is going to be a little bit taller. Okay, that looks fine for now. We can come back to that. Like I said, it's all procedural, so, you know, this still works, no matter how much or what size we give it. So, okay, what else do we want from our sort of side plank bit? Well, in the original bucket, I had this sort of offset between each plank. I wanted to give them like a different length, like it's sort of been hammered together, not hastily, but it just was maybe a sort of medieval thing. It didn't have really high quality craftsmanship, and we can do that. So what I'm going to do here is I'm going to create a group on our box, and I'm going to just look at that. Now I want to select, I'm going to call this top. I want to select the top face of our plank here, and I want to basically say, for each copy iteration, elevate that by some random amount. So how can we do that? Well, we know this has a consistent primitive number. No matter how much I change or scale this, that's always going to be the number that's at the top. So let's use that, because that's consistent. 5. So there's now a group, primitive group, called top, and if I down a blast node and I just blast away that group, delete non-selected, you can see that's the only face that's left. So that's what's in our group. That's helpful. I'm just going to hit L to organize my notes. There we go. Okay, so that all works. Let's turn that off. So we've now got our top group, and I want to know something about these planks. I want to know which copy iteration we're on, and there's actually something built into the copy and transform for that, which is this thing called copy num. That's really simple. We'll just turn that on. I don't think we need to do much more. We can see what that's actually doing here. That's creating a primitive attribute called copy num, and this is a bit of a problem. I want to make this a point attribute, right? Because I want to basically say, for each plank, take the top group and modify its position randomly, based on some random amount, maybe add a little bit to it, per plank. But the problem is that's a primitive attribute, and I want to move the points. Because if we look in our geometry spreadsheet, position is stored in the points. It's not stored in the primitives. So I need to get this to this. I need to get the copy num attribute onto some points. And I can do that with an attribute promote, like so. So I'll plug that in, and I'm going to tell it I want to update. So I'm going to say from primitive to point, I want this to update our copy num thing, or promote it rather, from primitive to point. And now if I look at this in the geometry spreadsheet, you can see copy num has been promoted successfully. Now this has been successful. You might want to turn on first match. It's essentially going to do the same thing in this case, but I'm just going to turn that on for safety, just to make sure the first thing it finds it's going to promote, and it's not going to try and average it between the two or anything silly like that. It shouldn't do, but I just want to be sure. So now I'm going to put down a point VOP, and we could write this in Vex. I'm going to write it in, I'm going to design it in a VOP just for sort of ease of viewing. We're basically going to tell this, if we dive inside by double clicking, we're basically going to tell this to offset our Y component a little bit every time we iterate through this. So how we're going to do that? let's say we want to start by splitting out our global position variable. So I'm going to say vector to float. Nope, wrong one. Typing it incorrectly. Where are we? Vector to float. Perfect. So we're going to plug that into our position. So this gives us our x, our y, and our z components out of this node here. And I just want to modify the y. So I'm going to take our y position and I'm going to add something to it. Let's add some random number. Okay, but random based on what? Well, let's bind in our copy num. Like so. That should be an integer attribute. Plug that in here. And we want our random node to give us a 1D output. Alright, we're going to add that in here. And let's plug that into our position. Well, that's going to break everything because we've just plugged back in one component into our position. It doesn't know how to handle this properly. So we're going to set, we're going to actually put down a float to vector now rather than a vector to float. And we're going to plug our x back into our x, our z back into our z, and this add node into our y. So it's our y plus something. Now that's our new position. Okay, so this has kind of worked. You can see for each iteration it's shifted or added some amount to the plank. But this isn't quite what I want. I want this edge to be flat. I don't care if this edge is a bit broken up. I just want this edge to be flat. So how do I do that? Well, that's where this top group comes in here. We can just tell this point VOP to go, hey, just run over the top pieces. And by putting that down, by tapping this menu here, it just runs over the top pieces. And this has done it fairly successfully. I'm just going to call this rand offset. Now it's worth knowing about the random node and also the random function in Vex. It outputs a value between 0 and 1 every time. And so we can take advantage of this to scale up or scale down the amount of variation we get. So one last node I'm going to put down is a fit range. I'm going to plug this into our first input, plug that into our add. Just going to organize this a bit better. There we go. So in our fit range, we've got a couple of things. We've got a source min and max and a destination min and max. Now the source min and max are fine because this is basically, like I said, this returns values between 0 and 1. And so this is the input range we'd expect, between 0 and 1. With other nodes like the anti-alias noise, you might set this between -1 and 1 because that's the output that node gives. If you've got a very specific attribute, so in this case with our copy number, if we wanted to plug this in, we'd have to see how many copies we had, and our range would be between 0 and however many copies we had. But for the random, it's good because it's between 0 and 1. We want to be able to control the destination min and max. And I don't want to control them down here. We could control them down here, but I want to make it a little bit easier. So I'm going to middle mouse click on each of these little circles here and click Promote Parameter. Just going to hop up here. And you can see this minimum value or maximum value have both been promoted up, and I can control this. So if I want to say, hey, you can't ever add anything that's a value of 0, let's sort of pull all of that up. You can see the range of these is decreasing because this number is getting closer to this one. If I make them equal, it goes away completely. They've now added 1, always 1, to each plank. If I pull this back down, then it's fine. We've got our range again. And I can increase this. I can say, hey, go really mad. Do something like that. I don't really want to, but we can do this. I'm going to set this so it's only a very, very small jitter. I'm just going to set this between like 0.45 and 0.65. Oop, typed that in completely wrong. How did I manage that? There we go. This is just going to give us a little bit of subtle variation between each plank. It's nothing mad. But you want it to feel like someone constructed this, they just didn't have maybe the tools to get it absolutely perfect. So that's good.
It's nice to be appreciated.
Thank you. That was Siri there. Now if we come back down to the bend node, this is all still working procedurally. I can still update all of my plank differences. I can still add more copies into this. It's all completely procedural, and it's exactly what I want. So that's good. We now need to make a bottom on this because a bucket without a bottom is a tube, and you can't store water in a tube. So let's go and pop down a tube. Bit counterintuitive, I know. And by plugging something into this first input on the tube, it's going to wrap the tube around that object. Now the reason I've plugged that into this transform as opposed to here, is if I plug this into here where we did our taper, I'm going to name this taper. If I plug it in here, the object that we get, if I reference it on, is going to be wider than the base of the bucket. It's going to take the widest point, and I'm going to use this tube to generate an actual base on our bucket. So how do I go about that? Well, I need to make sure I've got something that is of an equal circumference to the bottom, and so I'm going to plug in into this transform rather than the taper. We're going to create a separate stream. So that's all good. Let's set this into polygon mode, and I'm going to make this fairly high res. I'm going to give this 100 columns, something like that. Okay, and we're going to add some divisions, sorry, not divisions, we're going to add some ends to all of our to our divided surface here. So let's put down a polyfill, and you can see this is looking a little bit janky. We don't want to use that. Let's set this to a single polygon, like so. And we just want this bottom piece, so I'm just going to put down a blast node, and I'm going to say if your position in Y is greater than I don't know, 0.01, something really small, because you know this will always be taller than it, then, and your point, we should make sure we need to specify that in the blast, then we delete you. So it got rid of all of these points and kept these ones, which were the ones we wanted, and these ones form our bottom patch. We could have created a group here and then done some things with like a connectivity node and a split. It gets a bit too complicated there, so this is fine, because at the point where the bucket is really that short, it's a plate. So I think we're okay. So now let's pop down a poly extrude, like so. And I just want to extrude a little bit of depth into this thing here. So let's do that. Maybe 0.25 should be alright. Yeah, it's not bad at all. Okay, and we can see if we reference this on. Okay, cool. So this is extruded down. So now our bucket's got a base, kind of. It's got a completely flat base, and it's not got any details in it, and we want it to kind of look planky like this stuff. What was the kid from... It's just occurred to me, what's the name of the kid from Ed, Edd n Eddy, a cartoon that was on in like the 90s? I had a friend who was a plank. What was his name? I don't remember. Anyway, off topic. We're going to come in here and we're going to do a Voronoi Fracture. Like so. We're going to... duplicated it. Sorry. We'll plug this into our first input, and now we want to create a line that's basically going to represent the width of this again. So we can use that familiar B-box expression, which comes in handy all the time. So how do we want to do this? Well, I want to set the position of this line to be right at the outer edge of this circle here. So let's go ahead and do that. I'm going to use a B-box expression to say, give me poly extrude 1, like so. And then I want the X size of this. What does that give us? Okay, that's given us too much. Divided by 2. Okay, and that's placed a line perfectly on our edge here. So what else do we want? Well, we want to change the direction. In order to get this to point along here, this needs to be set to -1. So let's do that. And 0 and Y. So that's pointing correctly. Now we just need the length. So we're going to plug, we're not going to plug anything in. We're going to set our length to B-box, and we'll select or point it at poly extrude 1, so it's pointing at this thing. And we want to say, give us the D underscore X size, and we want the whole thing right the way across. And now this created a line that runs all the way across our surface. We can plug this in. Now, for those of you who didn't see my last tutorial or don't know how Voronoi works, Voronoi basically takes some input points and it splits the surface up based on how near it is to each of those points, basically creating cells. In this case, we're going to use it to split the this surface, the bottom of our bucket, into multiple planks. So how do we do that? Well, we've got it set up. We just need to increase the number of points here. And you can see, if I pop down an exploded view node here to our first output, we've split the bucket up fairly successfully here. Looks like chips all of a sudden, I don't know why. I'm going to set this to 5. It's what I had originally and it looked pretty good. Although obviously you can go in and adjust this as you want to. But again, this is completely procedural. If I change, say, the number of copies, okay, the size of the bucket is going to change, unless I change the size of this to compensate. But it's always going to fracture into 5 pieces. And this line is always going to draw itself completely evenly across the surface. And we can increase it, decrease it, whatever we need to do. So that's great. We want to do a couple other things. We want to poly bevel this Voronoi, so we just get that nice roundness that we had here. So I'm going to come in here, going to set our distance up a little bit, something like that. And already we've got a problem. You can see the edges are really screwing with me here. They're creating some very ugly surfaces. Even if we were to make this a lot less, you can see how hideous these triangles are. I don't want that in my mesh, and I don't want it to bevel an edge that isn't really kind of what we describe in the real world as an edge. So let's change what we're actually doing. I basically want to bevel from our extrusion the top and bottom faces. So I'm going to create 2 groups, and the poly extrude's got this built in. So I'm going to say of the front group, I want that, and I want the back group. And I'm going to shorten the names of these because I always think they come in too much or come in too long. So let's do that, and then let's say only bevel the back and the front. And now it's not beveling any of these side edges, which is kind of what we want. And you can see here, I can do an exploded view, and this looks pretty good. This is usable. So let's name them. It's going to be our out base planks. Oop. Out base planks. And while we're at it, let's pop down a null and name our bucket, I guess bucket shell. Out bucket shell. And we're just doing this in case we need to refer to them at any point in the future. So, okay, that's cool. Let's merge those together. Oop, like that. You will always have to forgive my terrible typing skills. So we've got that, and okay, this looks pretty good. Thinking from a surface perspective, it looks pretty respectable. Maybe one thing we might want to do is match the bevel on the wood, so we can come in and do this like so. Just come in and paste relative reference from our first bevel to our second, and that's just going to make sure they're the same bevel. You might not want that, in which case you could unlink them, or you could link them and add like a multiplier or a divider in there. But this is looking pretty usable. So what's next? Well, in the original bucket I had like some metal rings that went around the edges, and I want to do that here. So how am I going to do this? Well, let's put down a clip straight after our merge. And I basically want to use a couple of these to define where the top and bottom are. So this one will define where the bottom ring goes. Let's come in here and we can move this up. Now the clip's basically just going to remove geometry and create a new edge wherever this plane gets moved. So let's, I don't know, something like that seems pretty good. We will put down another clip like this. This one's going to be our top ring. In fact, I'm just going to colour these something different, maybe red, so we can, in the script, if it gets a bit long, we can find these and go, okay, so we'll build these into a control panel in a later video, but just for now. So we've got that. I want to change this to primitives below the plane, and I'm going to move this right the way up. If I had this on primitives above the plane, it would undo the work of our bottom one, so I'm using primitives below the plane for the top. And this is pretty good. I can reference this on to just see where they're going to get placed. Something like that. A bit higher. That seems alright. So that defines where I want these to be. So how am I going to actually do something with this? Well, let's pop down a tube, like so. And let's go ahead and make this a polygon mesh with 50 columns, just so there's some nice subdivs in there. And I'm going to pop down a polyfill, like this. And if we just turn on flat wire shaded, I'm going to turn off our reference here. This is again disgusting, so let's, you can actually, I should say real quick, you can set this to be less disgusting with a quadrilateral grid, which occasionally you'll get some bowing. I think I mentioned this before, but you can set this fairly high and it will flatten it out. This is much nicer, but we're not going to use it in this case, we're just going to use a single polygon. We do in this case want to turn on the patch group, and the patch group is basically so we can isolate this, which is what we're going to do right now. We want to basically keep those two top faces. So we've basically got a circle where each of these clips were being placed. So let's pop down that patch group here and turn off or delete non-selected. And so now we've got that. Nice. I'm going to pop down a poly extrude, and I basically want to connect that in, and we're going to extrude out. Now one thing I definitely wanted to do was invert the distance that this was going in, mainly because if this, I don't want either of these to cause it to hang off the edge, and you might want this to be right on the edge of the bucket. So I basically am going to invert the direction it's traveling. Now if I move this into the negative axis, you can see these surfaces are going to go sort of pinkish purplish blue, and this basically is to indicate that the primitive normal, if I visualize that on here, is inverted. This is pointing the wrong way. We'd expect to render this surface, not this surface, or this side. So the way we'd solve that is by putting down a reverse, rather than by inverting our distance. So I go here, put that in reverse, like so, and then I put this into the positive. You can see it's now going inwards, where before it was going outwards. And the reverse node by default will do that for you, so that might be one to keep in the tool belt. So the only other thing we want to do is we want to turn off output front, because we actually don't want that big circle. We just want the bands that we've created with our extrusion here. So that's all pretty cool. The other thing we're going to want to do is reverse it again. So I'll explain why. We're going to put down a ray sop, and this ray is basically going to take whatever geometry we feed into the first input, and it's going to fire it at whatever geometry we put into the second input. So we have that, and it's done that. Now, by default, it uses the direction from normal. We could invert this. We could set this up ourselves and give it a vector or something else, or use like a minimum distance method. That would work. I want to use the normal direction because I want it to go perfectly inward. I don't want to leave any room for obscurity there. So I'm going to put down a reverse. So that's going to now take that normal direction and fire it towards the original bucket. And I'm just going to scale it slightly off the surface here. Not anything major. I just want to give it a little bit of leeway, so it's not, there's no risk of it intersecting with the bucket. And then I'm going to reverse it again, so our newly conformed surfaces have outward facing normals like that. So that's all good. What else do I want to do? I want to create some thickness in those. So let's put down another poly extrude here. And we're going to just move this out a touch. Nothing too mad. That should do. We'll turn on output back. And those are our rings. Let's put down a null node here. Out rings. Now we can merge that into our stream. So this is going pretty well, apart from that last merge, which was horrendous. We can see, if I turn off our primitive normals here, that we have a procedural bucket that can respond to changes in its own surface. So I can decrease the number of planks, I can change the size of those planks, so I can change the amount of variation in our plank heights here. This is all completely possible with a procedural system like this. I actually really like where we were, so I'm gonna set that back. But you can see how effective this is and how you could create multiple buckets from one system. But I want to add more. So let's go in and add some nuts and bolts that we'd see used to sort of fasten this these planks to these rings and kind of create that shell, give it a bit more structure. So how do I want to achieve that? Well, I want to be able to extract this front surface from each of our rings, and we can do that again by isolating it using the groups built into our poly extrude. So let's do that. Let's again, I'm going to rename this something shorter. I'm going to pop down a blast node, and I'm going to get rid of everything except those. Nice. Okay, so now I want to basically extract all of these into points. So I'm going to do that using, well, let's start by putting down a facet. God, me and these node names. And I'm going to set this to unique points. And what that's basically going to do is that's going to say, hey, there used to be a single point here that connected these two primitives together. Now we want a point, even though they're on top of each other, for each of these. So if I look at the point numbers here, you can see this is point 68, and after the facet there's two numbers laid on top of each other's. It'll be 68 and 331 or something like that. So that's the use case was what we're using it for here. What else do we want to do? Okay, so we want to assemble these like so. And we're going to turn on create pack geometry. Now we can change the display of this to be Centroid here, which is going to give us a single point inside each of our polygons. If you want a really good explanation of what pack geometry actually is, you should definitely look at Applied Houdini Rigids 1, I believe it is. We'll give you a good explanation of what that is. But in this case, all you need to know is that we're generating a single point at the center of each of our polygons. And if I reference this on here, you can see that if I'd done this without doing the facet, the assemble would have only picked up each of these, and I wanted it to pick up each face, which is why I've done it this way, or added that facet, I should say. So we've got this. Now this is just setting a display. It's still got, if I middle mouse, it's still got 100 packed fragments in there, and I don't want that. I want there to be just points. So I'm going to pop down an add, and I'm going to say delete geometry but keep the points. Okay, so now let's create our little wing nut or something, not wing nut, I guess a bolt or something like that. We're going to put down a tube, and I'm going to set this to polygons, and let's just make this have 6 columns, something like that. I'm going to align it on Z because I know I'm going to copy it to these points later on. Let's polyfill like that. Quads are fine. Do quadrilateral grid, I get that. Quadrilateral fan I don't want. That seems okay. Yeah, let's go with that for now. And I'm just going to quickly poly bevel this just to kind of round those edges off a little bit. Something like this. Okay, let's create a patch group here in our polyfill, and let's do everything except patch. Is that gonna what I want? No. No? Okay. You know what, let's just leave it at that for now. We can come back and fix this later. So I'm going to pop down a transform. I want this to be a little bit smaller. And we'll just make this 0.2. Like so, that's fine. And let's put down a copy to points. Okay, so this has done kind of what we want. We need to do a couple of things for our copy to work properly. We're going to put down an attribute wrangle, and we're going to say at or vector at up equals set 1 or 0, comma 1, comma 0. So it's pointing up in Y. It's not going to change anything yet. We also want this to have some normals. So let's look at our incoming points. There actually aren't any point normals on here, which is a bit of a problem. We need these to point somewhere. And ultimately, we could come up with something fancy in code to make this work, but I think there's a better way. what I'm going to do is I'm going to come back up here, and when we do our blast, I want to initialize some primitive normals. So I'm going to put down a normal SOP, set this to primitives. Okay, as you can see, we've got some primitive normals on here, and I want to promote those up to our point level. So attribute promote, like so. Set this from primitive to point, and then tell it to use our n. The reason we've had to initialize here is because there were implicit normals, but there aren't any, even though they're kind of here, they're kind of not. They're not really initialized as an attribute, so we just put down a normal SOP to initialize them. So now we've got those promoted up to point level, so you can see now those are all pointing out. And if we come to our assemble SOP, I can say when it comes to transfer attributes, transfer the normal attribute up. And now when we look at our points, hey, there's our normals. We can copy the points. Let's turn that off. And this all works. We can merge it back into our stream here. I'm going to do... How do I keep screwing this up today? Let's merge those two together. I'm going to name this, or actually give it a handle that we can select from somewhere else. Out bolts. So this is great, but there's quite a lot of them. Even if we were to come in here and really scale them down, this feels kind of excessive. If you want some sort of, I guess, steampunk, I don't know, kind of thing, I don't know what you're going for, but this is this to me is a bit too much. So how do I reduce this? Well, maybe I don't want to use every single primitive to generate a point. Maybe I want to do less than that. So let's come in here and pop down a delete node. Plug this underneath our attribute promote, and I'm going to tell it to delete by range. You can see by default it's already selecting one of two pieces, and if I actually don't need this facet anymore if we're deleting this way. If I plug this in like so, it's all going to operate fine, but it's now selecting a certain number to kill, and to me this feels a lot nicer. I could say do 3 of 4, do even less. You might want some sturdier bolts, so you could come in here and scale this up some. Okay, maybe not that much, something like this. But you can come in and kind of decide how many you want. I'm going to stick with the default of 1 of 2. I think that looks pretty good. But again, this is sort of where the procedural nature comes in. You can come in and change that, and this will update again if we change this. Might get a bit squished, which is why you'd have to change other parameters, but that's fine. We expect that. Okay, so that's been fairly successful so far. Let's create the last bit, which is the handle. So I'm going to need to create 2 main pieces here. I'm going to need to create some hinges, and I'm going to need to create some like a handle, a big metal thing to go over the top. So alright, how am I going to do that? Well, let's start with a circle. I kind of want to make these things, I can show you what I'm going for. I kind of want to make these things look like this. I want them to have a bit of a square base, and then I want them to go up and arc over and do something like that, and then I want them to have a hole cut in. So it kind of looks like a padlock, but we'll have 2 of these, and the bucket will go, the bucket handle will sort of hook through this. So that's what I'm going for. See if we can actually do that. So I'm going to start with a circle, and I'm going to make it a polygon circle. It's on the XY plane, and I'm going to make it a little bit smaller. Let's make it 0.6, something like that. Up the divisions, and I'm going to put down a clip node just to clip this off. Okay, and now I want to select the points on the end. So it's a fairly reliable way of doing it. You'll get your start and end points will be the highest and lowest value in this number array. So let's do that in an attribute wrangle. Say in here, if your point number equals 0, or your point number equals the number of points in our array, So input 0, which is the first input on the wrangle. We're going to say -1, mainly because our array starts at 0, so we've got 26 points here, but the last one in the array is 25, so with 26 points, -1, 25. So that's that. If that's true, then we want to create a group called ends, so we're going to be a point group, because we're doing this in a point wrangle, and that equals 1, so you're in that group. So what did that do? If I middle mouse over here, I should see 2 points. Yep, in ends. There we go. Perfect. So now what? I want to promote that up. I want to promote that into the edges. So I'm going to put down a group promote. So let's just call this create ends. Plug that in here. And I'm going to say go from points to edges. And that ends group's going to go up. And you can see that's connected this stuff here. Okay. So let's pop down a poly extrude like this, and we're going to tell it we want to operate on our ends group. And we actually don't want to use the extrusion here. You can see this is going to really break it and look weird. I don't want to use that. I want to turn on transform extruded front, like so. We can turn off our point numbers here. And we're going to move this, well, down in our z-axis. Something like that. Looks pretty good to me. Okay. And let's scale this back a touch. Something like that. That was the value I had in my original script. Okay, so we've got that. What else do we want to do? Well, I don't want to cut this out. I kind of want to create that nice shell here. So I'm going to reference on this original poly extrude. You can see how much we've scaled it. And I'm going to put down another poly extrude, and I'm going to inset that back out. Now the inset is unfortunately not going to work, so we're going to have to do it with a scale. Fortunately we're on world 0, so we can use the transform extruded front again, and we can just scale this up till it kind of matches our original size. I think something like that's pretty good. And we're going to turn off output front. So now we've only got the sides that had extruded in our inset, but we've now got this sort of padlocky shape that we were talking about earlier, and that's what I'm going for. Let's put down another poly extrude to give it a bit of thickness. Something like that. We've got to make sure we turn on output back. Pretty nice. Okay, and now we want to copy this onto some point on our bucket. Now, we need to find a way of attaching this appropriately. So I've thought about this a lot, how we can make this work, and I think this is the best solution I've got. I'm going to put down an add, and I'm going to create a new point. And I want this point to be, like we've done before, on the furthest point out in the X size. So let's do that. Let's put down an expression that goes dbox. Give me, what are we looking at? Well, I want the base planks, so we'll use that handle, out base planks. And give me the X size. And remember, we want to just use half of it, so we're going to go divided by 2. We'll just reference that on. Okay. So this is helpful. We're going to want to move it up some. So let's do that. I don't know if I want to move it up by the height of our plank. Maybe let's try that for now. Just grab this, copy parameter, come back down, paste relative reference here. Let's move it up to an OK location. We might want to move it outwards eventually. I don't know. We'll think about that in a moment. We're going to want another one of those because we're going to want 2 of these. So we're going to put down a copy and transform. And again, we're all oriented on world 0, so I can come in here and just say rotate it 180 degrees and There you go, we've got a point here and a point here. That'll make them easier to see. And we're going to use those as copying points for our little hinges here. So our hinge goes in the first input, and our copy to points goes in the second. Okay, so this isn't perfect. We need to reorient these. So what I'm going to do is I'm going to make sure that the points are completely conform to the surface. So I'm going to use another ray sock here. And I want to fire these points onto this surface. Now here's an example where we could use a minimum distance, but I'm a little skeptical. I don't even know where those points went now. So let's not use that. Let's use a project rays. We're going to, at this point, where are we? In fact, we'll do it just after the add. We're going to make sure that this is pointing outwards from 0. So I'm going to put down a wrangle, and I'm going to create a vector, just a, we'll put it 0 equals 0, 0, 0, so our world 0, and then I'm going to say at n equals normalize 0 minus our position. What does that give us? Okay, so that's now pointing towards it. Let's just invert that. Times -1. Boom, it's now pointing outwards. And when we rotate the point, okay, they're now pointing outwards respectively. And then we know they're inside the bucket because they took the narrowest point. So we can now fire those outwards, hopefully. That work? Yeah, that worked. And they have fired into these little holes, so we might want to just rotate them around a little bit. Something. Still pointing upwards. It just means, yeah, or we could tell you what, we'll come up to here, we'll set this to 18 now. No, we won't. You know what, I think this is fine. We can come back and solve it if it becomes a problem. I don't think it will though. So we've got that. We're going to use these as our new points. I'm just going to alt-click to create a little button here. Like so. Okay, and now, because they've got normals, they're aligned correctly, and this was built on Z. So that's all good. They're a little bit too in the bucket, and they're a little bit big, so I'm going to scale them down again to something maybe like that. And then I'm also going to translate them up. So that's pretty good. I might want to just shuffle them out a little bit. Again, this will be a little offset control we can give ourselves in a control panel. But just something like that. So now we've got our handles or hinges in the bucket, and that's pretty good. You might want to change this around as you know, if you were to randomly scale some of these planks. But this is okay for now. So let's just call that out hinges. There we go. There we go. Okay, we can merge this into our stream too. So we've got our little bucket here, and we want to create a handle for it. So this is probably going to be the trickiest part of what we're going to be doing, but I think we can do it. So what do we want to do? Let's create a circle, because I know what I want this to have a nice sort of big arc here. I just kind of want it to be flat for a handle on the top, and have two little curved bits to hook around here. So let's create a circle, and I'm going to make this the radius of our hinges. So let's put down a B box. Let's say out hinges, and we want the X size divided by 2. There we go. This should be polygons, by the way. So what's that giving us? Should probably move this up. Let's move it up to where the hinges are. Let's say we want the centroid of our hinges, and I just need to give it d_y, and that'll give me the y centroid. Okay, so this has created a handle or a circle with a radius that is completely between these two handles, and that's pretty good. Let's make this a complete circle. So I'm just going to right click and copy this into this, so that it's operating on both axes. It's a complete circle. So that's pretty good. Now I just want to curve out of this, so I'm going to set this to an open arc, and I'm going to set this between 0 and 180. It's going to give me that. You might have to play around with these values. You might need to go between like 90 and 270 or whatever else. In my case, 0 to 180 works. I'm going to give it more divisions, give it like 100 divisions. It's fine. And I want to scale it slightly inward because I want these to come round on the inward side. So let's just something like that's pretty good. Okay. So let's put down a clip. I'm going to build this on one side and then mirror it over to the other. So we'll just say the direction in 1, and that gives us this semicircle. And I want to blast out our first point. So, or everything that isn't our first point. There we go. Points. There we go. So that's given us this point here, which I want to use to copy another circle onto. So I'm going to create a copy to points. There we go. Plug that in over here and create another circle. And I kind of want to define the size of this manually, so I'm going to use some parameters I had before. That's pretty good. I want the center of this to be, so if we look at what this has generated, I want the center of this to be again on just off world 0. So I'm going to say copy parameter, paste relative reference on this, and you can see that the edge of this is now on world 0 and the centroid is just off to the side there, because this is the radius, not the circumference. So we're going to need, what do we need for this? We'll set this to polygons. We'll give this some divisions as well, and we'll set this to an open arc. 180. There we go. So that's the inverse of what we had over here. So we've got a bit more of a hook. That's great. And we're going to copy that to these points, or this point, I should say. What does that give us? Okay. Okay. It's not perfect, but I think we could work with it for now. Let's merge these together. So we've got that as a shape. That's pretty good. And I'm going to put down a join node just to connect these two lines. Just default's fine. And then put down a smooth just to kind of smooth that out a little bit. There we go. So now we can mirror this. Put down a mirror node. And the x-axis is already working. So this is pretty good as a handle. I want to flatten the top off, so let's do that. Let's grab a transform node here. And I'm going to set the pivot to be the location we want to use for sort of scaling these points down rather than translating them. So I'm going to say, if we turn the handle on, where do we want this to be? Where do we want our handle to go flat? Maybe there's pretty good. Let's try that for now. I'm going to copy that parameter, and I'm going to say at P is greater than whatever that is. I'm going to set it to points, and I'm going to set the scale in Y to 0. And that should have worked. Oh, I see what I've done wrong. I need that to be the Y position. There we go. So now, back to perspective. Now we've got our flat handle. We can control this. We just have to come in here and shift this number around to decide where we want our handle to go. So that's great. We need to give this some thickness. So I'm going to put down a poly wire, like so. We're going to give it some subdivisions, so 20, we'll go fairly heavy on that. And we want to give it a bit of a thinner radius, maybe? Something like that. Now this is a consistent thickness, which I think looks pretty good. I'm going to show you a technique now for generating the handle, and if you want to apply that as a width attribute, you can just literally just plug in here like that, then we can do that. But in this case, I think this looks pretty good, so I'm going to keep it as is. Let's name this as our out handle bar. There we go. I know some people are going to be shouting at the screen saying this is interpenetrating and this isn't working. We will get to that in just a second, so don't worry about it. So let's create a line. And what do I want this line to be? Well, I want this line to be at the highest point on here plus whatever the thickness of our poly wire is. So let's start by doing that that maximum position. I'm going to say give me the bounding box of our out. Put the inverted commas in. There we go. Of our out handlebar. And I'm going to say d underscore y max. What does that give us? Okay, so now we've got a line that's right here, but that line is placed perfectly on the top of this, and I want this to inform, I want this to shoot straight through the handle, and this is going to inform where that handle is. So I need this to be a little bit lower. So I'm going to divide this value in the poly wire by 2. Whatever we set that to, this line is going to be. So I'm going to say that minus, just open my brackets here, right click, I didn't put a bracket down, put a bracket down. I'm going to go paste relative reference, so I've got that polywire radius divided by 2. And now, should be able to see that this is sitting in our polywire. I don't need to divide that by 2, do I? No, I realise I've done that wrong. Let's not divide that by 2. You can just, there. Okay, there we go. That's better. Well, that was a bit off. So let's set the direction to 1, so it's in X, and it's going along our handle. And we're going to set the length to something that looks pretty good. Again, this will be something we can give a control to see how long that sort of wooden handle piece is going to be. I'm going to give this some subdivisions. It's going to be pretty cool. And I want to put down a resample. Now, we're not going to use this to resample the number of points as one traditionally would on a line. You can see here, if I look at this before, by default this is resampling them by a spacing agreement. I can set this to maximum segments and force a particular point number evenly along that line. I'm not going to do either of those. I'm just going to turn on this curve U attribute, and I'm going to use that to create a profile. Now we could do this again in a wrangle. I'm going to do it in a point VOP for ease of viewing, especially if you're new to Houdini. So I'm going to plug this in here. And basically what you need to know about that curve U attribute is it's basically creating a value between 0 and 1 along this line, which I can visualize. I can just go into our point VOP, bind in our curve U attribute, which is a float, plug that into color, up, turn on our point VOP, and you can see here, it's black here and it's white here. It's going from 0 to 1 along the length of that spline, and we can make use of that. So what we're going to do is we're going to do a vector to float, and we're going to extract our Y position again, and we're going to basically add something to that. So we've got our curve U. Now I want to use a ramp parameter. Now all ramp parameters, whether they are of an RGB type like this one, or we're actually going to use a spline ramp like this, they all expect an input between 0 and 1. Now we can use our trusty fit range to set that. Fortunately for us, the curve U by default will set a range between 0 and 1. As long as we don't modify this curve after this, then it will be accurate and linear along our line. So we plug that into our ramp and add that ramp into here and put down our float to vector and reset. So we want to say our x is still our x, our z is still our z, and our y is now our y plus the value created in this ramp. Just going to hold down Y and drag, click and drag to disconnect that wire. And I'm going to just plug this in as our new position here, like so. So by default, this isn't going to do anything because this ramp is flat. Let's make it do something. Okay, not bad. We can now start creating shapes along the profile of this ramp. But I want a bit more control than this. I want to be able to use the full range of this ramp to create something, and I want to be able to control sort of how high it goes after the fact. So I'm going to dive back in. I'm going to add a multiply after our ramp, and let's just make this a little easier to read here. Something like that. I'm going to middle click on our input 2 and I'm going to promote that parameter. Now I can click on this thing here and I'm just going to change it to multiply and this label to multiply. So you can put down a parameter node and connect this and do exactly the same thing. I'm just middle mouse clicking because I think this looks neater in the network. And so now I've got this multiply value. So you'll see if I move this ramp, it's going to do nothing. But if I start upping this multiply, I've now got that control over how much it actually does its thing. So that's kind of perfect. I'm going to reference this on. So yeah, we want to start it thick here. Maybe go for a little flourish and a design on the end here. So let's do that. I'm just going to delete that middle point, and I'm going to set both of these to be a B-spline interpolation. So let's up the value of that and up this. I'm going to set this to 1 for now. So I want this to be fairly flat, something like that. And then it's going to come right the way up again, and I just want to dip somewhere like that. That looks pretty good. And we can change our multiply. We might want to bring that down more aggressively now. There we go. So that's pretty nice. Let's revolve this. We need to make sure this is revolving around the x-axis. Look at that, it's a dinner plate. Let's revolve it around our... do we want to revolve it around x? Yes, we do. There we go. We want to make sure that the origin of this isn't at 0, because you can see this is massive at the moment. We want the origin to be wherever the origin was here. So I'm going to right click on that and paste relative reference into here. And there we go. We've got our nice little handle there. What else am I going to do? I'm going to mirror this so it is mirrored along the other side, so we've got a consistent thing. And we can come in here and be way more detailed about, you know, how some of this stuff's going to look. Something like that, maybe. A little bit more of a handle, so you grip 1, 2, 3, 4 fingers. Yeah, that would work. Maybe we can move this down a touch at the end, something like that. Okay, that's all good. We're going to put down a fuse and just fuse those two ends together. And we're going to put down a poly extrude again. Now, I'm not going to reverse my normals because I want these to go inwards. I want these to line up against this wire here. So let's put down our poly extrude and just add a little bit, something like that. That looks alright. We don't want to go too thin because we don't want it to poke through like it is here. It's going to be alright because we can just say turn on output back and it doesn't look too bad. I don't think you'd notice that. And I guess someone who was actually manufacturing this would drill right the way through that whole thing. So that's fine. Let's name this or null down again. Let's call this out handle. Merge them back together. So our little thing. And there's our handle. Looks pretty good. We can adjust where it is, like so. So that's pretty cool. If it goes inwards, we will have to adjust the length of this, but again, parameters to right. So that's pretty good. We're going to put a transform down so we can just adjust this as we need it. Let's move that. Oop. Move that. Align it. Plug that in there. And there we go. Let's put down that transform and just offset this slightly upwards. Something like that. Nice. So the last thing I'm going to do is I'm going to put down a clean node just to clean up some of our unneeded attributes. I'm going to turn off remove degenerate primitives so we can sort those if we have an issue with those later. We're going to give it some normals, so let's initialize those. Okay, and let's label this out bucket like that. So this has become a fairly extensive little tree, but it's all good. And the last thing, just to show you what I did at the beginning of this tutorial, put down a connectivity node just to isolate each island of geometry. I'm going to set this to primitive mode and pop down a color. Set this to a primitive color because that was the same as our connectivity. Random from attribute and class, which is what this generated. And there we go. Those are all of our pieces for our bucket. So thank you very much for watching this. I do hope you enjoyed it and maybe you learned something. Maybe you didn't and you stopped watching 40 minutes ago. But until then, thank you very much for watching. I'll be back hopefully with another tutorial pretty soon. Please leave suggestions in the comments for things you'd like to see me, either model, texture, effect stuff, anything Houdini related. I'd be happy to help you out with any problems you've got. But until then, thank you so much for watching this video. Please like, comment and subscribe, and I will see you guys in the near future. Take care.